All right, so we're doing lesson 22, simple linear regression. Getting close to the end of the semester. Trying to figure out these last few things out. Um, but yeah, let's just go ahead and start. Nothing. Some of the parts were difficult. I don't know about for you.
Yeah, well, I didn't see the video, so but trying to do it by myself. I
Yeah.
got something figured out, but hope it's fine.
All right, let's go ahead and start. Then you go ahead and start with two or three.
Okay. For number three, I give you the linear regression equation, which is y equal 2.0 plus 1.x. What is the y-intercept? And for that one, I got 2.0.
Yep. Yeah, because it's that one right there. And then it asks for that same equation. What is the slope? And it's gonna be 1.5.
Yeah, and for number five, give the linear regression equation. We just use the x value and put it multiply by 0.25 plus minus 3, and we got 1.0.
Yep. Perfect. And then for number 6, make a scatter plot of the math self of
Efficiency.
no,
Efficacy.
it's eff- effic- efficacy
Efficacy data.
efficacy. I don't know. Data. The three data shapes, including introducing the reading, which is the best. So once you put that into the uh, to the spreadsheet, it's a hot dog shape.
Which one is that?
Hot dog shape.
Okay, that's what I did it too. So,
Yeah.
uh, so well, for based on the shape of the scatter plot, you produce in question C what you can say about the appropriate of using simple linear regression to model this data. So I'm not quite sure about this one, but I think it's the simple linear regression is appropriate for this data.
Yeah, so if you look at the wiki,
Hmm.
that's the one I got too, is the last one. But if you look, it gives you specific ways it's supposed to be, each one is supposed to be talked about.
Hmm.
I'll find it. Here it is. So it says that when it's a banana and hamburger shape, the linear regression is not appropriate. And then it says, and then for the hot dog shape, it says conduct regression analysis to determine if the sufficient uh, if there is a sufficient linear relationship, and because it's that straight, basically that straight line, that's what I went with.
Perfect. And
All right. And then how many observations are in the data? And I put 139 because that's how many pieces of data were found.
yeah, and that same data we use it for question 10 to 13 as well. And they ask in number 9 for the y-intercept using the data. So it's what we got for y-intercept is 1.291
Yeah, just putting that in the
in the spreadsheet.
the spreadsheet. Yeah, and then
And
the
then we
slope
got
is going to be point zero or 0.042.
yeah, again, and we just pulled this value on the spreadsheet. That was it.
Yep.
And for the what is predicted value for y when x is 4, we got 1.4 459.
Yeah. So that you just find that you multiply 4 by the slope, and then you add the y-intercept to get that value for the prediction of a 4. And it says the confidence data results students evaluating their confidence of each question on a scale of 1 to 6. What is the maximum predictive value of y for these values of x? You should be exact. Hint, there is a positive correlation. You can use the largest x value to find the predicted y. And I got, from what I understood, it was 1.54, but that one I wasn't sure about.
For
Hello?
that, yep, for that one, sorry. For that one, no, I'm not sure either. So
Yeah, well, we'll just have to ask about that one.
Yeah, because I have no idea about that one. And for how many explanatory independent variables are present in a simple linear regression?
Wait. Go for it. Go ahead, talk.
Yeah, it's I would think it might be more than two.
No, I messed that one up. I figured it out. I just thought about it. Um, it's actually one.
Okay.
Both of them are one because there's only one independent variable and there's only one dependent variable. The independent variable being the score, and the dependent is their confidence level, the 1 through 6. So there's only one of each.
Okay, so it's gonna be 1 and 1.
Yeah, 14 and 13. So there's only one independent and one dependent variable.
Okay, cool. Okay, perfect. So we'll see how we go. So how we go. We got 9 through 12 wrong. I don't know
9 through
why.
12.
Yep.
Yeah, see that one.
I don't know why.
Maybe I think it's because we put in. Sorry, baby. Maybe we put in the information backwards.
You think so?
That's what I was thinking.
Well, we can look it up then later for the home.
All right, sounds good.
Okay.
So we got to make sure. So yeah, no problem. We can go ahead and do that. All right, man. Well, we're getting together. I think Saturday, right, to go ahead and finish up those last few things on the data. Probably need to get that other sheet he wants in earlier. So we might want to try to get that in before tomorrow so we can grade it.
Yeah, we can do that. I have quite a few times in it tomorrow, a few hours to do it tomorrow. So I don't know if you want to get together tomorrow or anything like that.
We'll figure it out. We can text back and forth and figure out. I don't know how much time I'm gonna have tomorrow, but we'll figure it out.
Okay, let me know then. Okay.
All right, cool, man. Catch up.
Okay. Okay. See ya.